Here with method of locating instantaneous center of rotation in a mechanism. If we consider 4-bar mechanism, first of all, we have to determine the number of instantaneous center of rotation by using the formula. So we have 4 links, then number of instantaneous center of rotation is equal to 6. Second, we have to make a list for these instantaneous center of rotation. Okay, we have 6. Using this table, we have to list here 1, 2, 3, 4 links. For the first link, we'll make instantaneous center of rotation I12, I13, I14. All of them starting by 1. Here, for the second link, we have to list I23 and I24, also starting by 2. For the third one, okay, we have I34, starting by 3. Okay, and for the fourth link, already done. Okay, we have I14, we have I24, we have I34. Okay, this is the location on this figure of all these instantaneous center of rotation. Let's see here. Third point, locate the fixed and permanent instantaneous center by inspection. In the figure below, I23 and I34 are permanent instantaneous centers. Okay, so I14, I12, I34 between 3 and 4, I23 between 2 and 3 are the primary instantaneous centers of rotation. How to find I13, I23, and I24? So the 4-bar mechanism has 4 turning pairs. Therefore, there are 4 primary centers, instantaneous centers of rotation, fixed and permanent. Okay, and are located at the centers of the pin joints. Now, the instantaneous center of rotation I13, you can remark that is the intersection between this straight line, I14, I34, and I12, I23. Okay, if we make the circle diagram here, so we have here link number 1, link number 2, link number 3, link number 4. The first instantaneous center of rotation between 1 and 2, 2 and 3, third one between 3 and 4, fourth one between 4 and 1 are the primary instantaneous centers of rotation. Okay, remaining the fifth center of rotation between 1 and 3, okay, and this number 6, the instantaneous center of rotation between 2 and 4. So to find I13, which is 5, I13, which is 5, we have to trace the line, draw the line, I12 here, the first instantaneous center of rotation, and I23, the second instantaneous of rotation. Okay, to go from 1 to 3. We have to pass through I12 and I23, I12, I23, and 1, 4 to 2 to 4, 3. So draw the line I14 and I34. Here I14, I34, draw the line. So the intersection here, it is what? I13. By the same way, how to find I24? We can see here. Number 6 is what? Is I24. How to find it? So going through I23 and I34, okay? I23 here, I34 it is here, we draw the line. By the same way, I12 and I14, I14, I want to draw the line. The intersection is what? The intersection is here the I2, 4, the theory of machines. We will continue with calculation of velocities in slider crank mechanism, for example. Here we have the slider crank mechanism. This is space diagram. We want to draw the velocity diagram. The slider crank mechanism have 4 solids or 4 links. So the ground, okay, the ground, here also the ground, okay, connect the crankshaft, connecting rod, and the piston. Okay. Steps for drawing velocity diagram are the following. We will start here by drawing point O. After that, so the piston point A here have a velocity VA, linear velocity or linear motion here. We have to draw VA as a given scale, with a suitable scale here, and parallel to VA. After that, we have to draw from point A here a line which is perpendicular to AB. Okay. Now we have to draw a line. We'll draw a line passing through O and parallel to VB. So VB is perpendicular to OB in the space diagram, because OB makes a rotation about O. The intersection here is the point B. Now we have velocity of point B. Already done velocity of point A. This green line here between B and A, this is what? This is the relative velocity VAB. And we have the rule WAB is equal to VBA divided by AB. It is equal to distance, algebraic distance AB divided by the distance AB. And AB link moves anti-clockwise about A. Let's see now if we have a point E, okay, like here, the point E on the solid AB. So the absolute velocity of any other point E on the connecting rod AB may also be found out by dividing vector BA such that BE divided by BA equal to BE divided by BA on the space diagram. So this is done by drawing any line BA1. Here we have A1. So the orientation will be anyway. So equal, the condition is equal to length of BA. This is the length of BA. Okay? But the direction anyway. Mark BE1 here, BE1 equal to BE, equal to BE, distance. Okay? Here, BE1 equal to BE. Joint A1 by this line. From E1, draw a line E1E, E1, this line, which is parallel to A1. Okay? The vector OE, because now we find the point E, and then we can draw the vector now represents the velocity of E. This is VE. Okay? This is VE. AE here, AE represents the velocity, the relative velocity of E, the point E, and the direction of path of B is given. This is the direction of path of B. The acceleration of the point B is determined in